Greetings, detectives. Mrs. McKay here, and we are on Case 5, Excellent Exponents, and we're starting our fourth clue. And let's go ahead and start by writing it in. I can represent reflections of functions in graphs, equations, and coordinate notation. Looks like I've written coordinate twice, so you can just draw that line through that. I can represent reflections of functions in graphs, equations, and coordinate notation. So that's our learning target clue. So last clue we talked about translations, where we slide functions around and the graphs of those functions, and now we're going to talk about reflections, and a reflection is just a flip over a line. So let's do that quick review. Reflection is a flip. Okay, or imagine if you were looking into a mirror and you see a reflection of yourself, you see basically the image on the other side of a line of reflection, the mirror being the line of reflection. So a line of reflection is the line that you flip your image across, and in this situation we're going to be flipping lines and exponential graphs. So I want you to think a little bit about reflections, and I want you to think about the number line, because you've done reflections without ever realizing it. If I have the number -2 and my line of reflection, I shouldn't say -2 there, we'll say if I have the number 2 and my line of reflection is 0, then if I wanted to reflect 2 across the line of reflection, which is 0, it would land at -2, correct? So that's a reflection. When we see that 2 is the same distance away from 0 as -2 is, that those number 2 and -2, they're reflections of each other. Okay, so that maybe will help you to understand the idea of reflections, and I think you've probably done some of this before. Let's get started though by talking about linear reflections. So when we want to reflect a linear function, we can reflect it over any line we want. But for this clue, we're just going to be talking about reflecting over two main lines. The first line is over the x-axis, and the second one is over the y-axis. And we're going to see how that changes not only the shape of the graph, but also how the points change and what the equation looks like. All right, so we're going to be looking at it in graphs and equations, and then we'll end up saying what happens using coordinate notation. So let's start with this line that I have graphed right here. F of x equals 2x plus 1. You can see that my y-intercept is at 1. You can see that my slope is 2 over 1 because I go up 2 and over 1, right? Up 2 over 1. Up 2 over 1. So let's start by just recording a few of these points. All right, so I'm going to put some points right here. I've got this one, this one, this one, and let's do this one right here as well. And what I'd like us to do is I'd like us to go ahead and write the coordinates of these points where it says f of x. So we'll start with this one right here. The coordinate of this point right here is -1, -1. And then the next point is 0, 1. And you go ahead and do the next two. Get those done. Okay, now that we have those 4 points recorded, now what I'd like us to do is I'd like us to reflect them over the x-axis. So let's start with this point first, right here, -1, 1. If we were going to take this point and flip it over our x-axis, which is right here, where would it end up? Well, it would be the exact same distance from the x-axis on the other side. So this is 1 away from the x-axis. If we start here at -1 and we just go down to the point on the line, we see that it's 1 down. So instead of going 1 down, we'll go 1 up. And I'm going to do this in a different color, I think. So right there. And then this one right here, which is at 0, 1, needs to reflect over to the other side of the x-axis, and so it's going to go right here. And then, of course, this one over here, 1, 3, is 3 away from the x-axis, so we're going to go 1, 2, 3 this way, and then this one will bring down 1, 2, 3, 4, 5. So we'll go 1, 2, 3, 4, 5. And there I have my points that I've just reflected over the x-axis, and I could draw my line something like that. All right? And I've just reflected my line over the x-axis. So what I'd like us to do is I'd like us to look at this and notice some things about this line. First of all, let's remember what our original line was, this blue one, and the equation of the line was 2x plus 1. So I'm going to write that right here just so that we remember. 2x plus 1. And now I'd like you to figure out what the equation of the red line is. What is the equation of the red line? Well, the y-intercept is -1, and the slope is down 2 and over 1, so it's a -2x. So the slope of this line is -2x minus 1. So what do you notice? Do you notice that when we reflected over the x-axis, everything in the equation became a negative? Well, I hope you did, because really what happened was we took the negative of f of x. So when we have our original equation, which was f of x, or our original function, which was f of x, when we want to reflect it over the x-axis, when we reflected each point over the x-axis, we kind of flipped it over itself, then we got the negative of f of x, which is a negative f of x. So that means everything on that side became a negative. All right? Now, let's go ahead and write the points. That's what we should have done actually originally, is write those points that we created. So let's pause it and write the points of each one of these. So when we reflected the -1, -1, it became a -1, 1. And you go ahead and do the other points. Okay, so I paused it and I went ahead and figured out each of those points, and hopefully as you're matching them up you see the same ones that I've written. But what do you notice? Do you notice that the x stayed the same, but the y is what changed? The y became the opposite. So -1 for the y on the f of x on our first point became a 1. The 1 became a -1. The 3 became a -3. The 5 became a -5. So this is important to notice, and it's really easy to see when you actually just do the flipping, but I want you to notice that in the coordinates, when we did the reflection, our xy translated to x stayed the same, but the y became the opposite. It became a negative y. So for example, negative 1 translated to negative 1, 1, because the negative, or the opposite of negative 1, is a positive 1. That should be a negative right there. Okay? So that's flipping over the x-axis. Now let's flip something over the y-axis, shall we? So let's start by doing the exact same thing, writing down our points for f of x. So we're going back to our original. So go ahead and write these same points, negative 1, 0, 1, over here. Okay, and this time we're going to take these same points, but instead of flipping them over the x-axis, we're going to flip them across the y-axis, and here's our y-axis, right? So we're going to take each point and we're going to just flip it or reflect it over the y-axis, all right? So let's start with our lower one, negative 1, 1, and we're going to flip it over to the other side of the y-axis, and it goes right there. And our new point, I'll go ahead and write our new points this time, is 1, negative 1, okay? And then this one that's sitting right on the y-axis, it just sort of turns over on itself and it stays the same, doesn't it? 0, 1. Okay? And then this one up here, if we were going to flip it, it would go over to this side. And so it becomes negative 1, 3. And this one comes over here, and it becomes negative 2, 5. And we could connect our points to make our graph, and you can see we've now flipped this over the y-axis. All right, we've flipped it over the y-axis. Now, let's talk a little bit about our coordinate notation. What did we notice happened? So we had our x and our y, and when we reflected it over the y-axis, notice what happened. Our x value became the opposite of the previous one, but our y values stayed the same. So xy transforms or reflects to negative xy. So when we look at our first point, negative 1, negative 1, it became 1, negative 1. The y stayed the same, but the x value did the opposite. All right, so now let's take a look at the equations and see what changed on the equations. So remember, our original equation was 2x plus 1. And let's take a look at the graph of this green line and write the equation of it. So our y value, our y-intercept is at 1, and our slope is down 2 over 1. Down 2 over 1, so negative 2x plus 1. What do you notice about the slope of this line compared to the slope of the other? Well, it's the opposite, isn't it? The first slope was 2 and the second one was negative 2. But the y-intercept didn't change. The y-intercept stayed the same. It stayed a positive 1, just like it was here. All right? Come back and we'll do some reflections of exponential functions in our next video.